It is February 14th, 2026. Happy Valentine's Day. I hope you got flowers or chocolate or maybe, considering what we're talking about today, a dedicated server instance.
Huh. That's really more useful.
Because honestly, the ground in AI, it really shifted yesterday. And I don't think everyone's quite caught on yet.
It really does feel like one of those before and after moments. And not about romance. We're talking about the end of the session.
Let's just start with a pain point.
Right.
One that every single person listening has felt. You know the drill. You open up a chatbot.
Right.
You spend like 45 minutes crafting the perfect context.
Yeah.
You paste in your project history. You explain the tone of voice. You upload PDFs. You finally get it up to speed.
You accidentally close the tab.
Or your wifey flickers. Or you just, go to sleep.
And when you come back, blank slate, total amnesia.
Exactly. The amnesiac chatbot syndrome. You're back to square one, introducing yourself all over again to a machine that has zero object permanence.
It's so frustrating. Well, that frustration is, believe it or not, a feature of the architecture we've been living with. It's what we call reactive AI. It sits there passively, waiting for you to poke it.
And it's stateless.
Exactly. The moment that session ends, the brain is wiped clean.
But imagine if that wasn't the case. Imagine an AI that doesn't just wait for you, but it keeps working while you're asleep. An AI that remembers what you told it last week, last month.
Without you having to re-explain everything from scratch. That's what we're unpacking today.
We're looking at a technical breakdown published just yesterday, February 13th, by Mrs. Singh. It's called Manus AI Always-On Agent. Features, architecture, and use cases.
And we've also got some breaking alerts on this from Testing Catalog News.
And just to set the scene, the source material notes the tech world is really heating up. There's this one line in there about how Meta is coming for it, OpenClaw.
Ooh, yeah. The corporate drama in early 2026 is definitely spicy. But our mission today isn't the gossip, it's the architecture. We need to strip away the hype and figure out how this always-on agent works, why it's so different, and, well, if this is the end of session-based AI as we know it.
So let's get into it. Reactive versus autonomous. Like I said, the status quo is, I type, it replies, the session ends.
Right. Traditional AI is entirely interaction-based. You have to be the driver. If you stop driving, the car just stops.
Dead in the road.
The Manus shift, according to this breakdown, is towards an autonomic system, an agent that operates continuously beyond any single session. It's all about persistent operation.
I was trying to think of an analogy for this. A traditional chatbot is like a freelance contractor.
Okay.
You have to rebrief them every single morning. Okay, here's the project. Here's what we did yesterday.
And if you don't brief them, they just sit there drinking coffee. They don't do anything.
Exactly. But this Manus Always-On agent sounds more like a full-time employee. You hire them, you give them a desk, they settle in.
And they remember yesterday's meeting?
Yes. And crucially, they might stay late to finish a report, so it's ready for you at 9 a.m. You don't have to reintroduce yourself every single day.
That connects perfectly. The source material explicitly says ongoing workflows without manual intervention. That's the key phrase. It's the difference between a tool you use like a hammer and a system that runs like a generator.
Okay, let's pop the hood then. The source lists 5 core features that make this happen. And I want to go through them one by one because some sound a bit like marketing fluff until you really dig in.
For sure.
First one. Dedicated computer instance.
This is fundamental. If we stick with your office analogy, traditional chatbots are like hot desking. You grab whatever seat is free, you do your work, and you leave.
You can't leave your papers out.
Exactly, because someone else needs that desk. In tech terms, standard AI runs on shared clusters. Your request spins up, gets processed, and the resources are immediately reallocated. A dedicated computer instance, a DCI, means the agent gets its own private room.
So why does that matter so much? Is it just about privacy?
Security is a huge part of it, yes. The source mentions enhanced security and an isolated computing environment. Enterprises, they don't want their data floating around in shared memory.
Makes sense.
But it's also about reliability and persistence because it's a dedicated instance. Think of it like a little virtual machine that never shuts down. It can run tasks continuously. It's not fighting for resources. It has a place to live.
So it has a permanent residence, a room. Got it. Okay, feature number 2, persistent memory. We've touched on this, but how is this different from just like a really long chat history?
That is a crucial distinction. A long chat history is just a text file, a log. The AI has to reread the whole thing every single time to remember.
And that eats up processing power. And eventually you hit the dreaded context window limit.
Which we still hit. even in 2026.
Right.
With persistent memory, the system isn't just rereading a log, it's retaining information in a structured way. The source calls it context continuity, and it allows for behavioral adaptation.
Behavioral adaptation sounds interesting. What does that actually look like?
It means the agent learns your preferences. If you always tell it, hey, I need my summaries as bullet points, it writes that preference to its long-term memory.
So it doesn't forget the next day.
Or 3 weeks later, you ask for a summary, it just gives you bullet points without you having to ask again. It builds a model of how you work.
That is a dream for anyone who's ever had to write a 3-paragraph prompt just to get a simple email in the right tone.
It changes the relationship from a series of transactions to a real collaboration.
Okay, feature 3, the skills framework. The source says skills are controlled, repeatable actions. How is that different from me just asking a chatbot to, say, write some code?
It's the difference between talking about doing something and actually doing it. I mean, when you ask a standard LLM to write code, it generates text that looks like code.
It's just text.
It doesn't usually run it or test it, it's sort of hallucinating the action. But here, the source lists specific skills. Data analysis, API integrations, document generation. Skills means a library of actual tools the AI can use. It has API keys, it has access to a terminal.
So if I say analyze this data, it's not guessing.
No, it's probably spinning up a Python environment, loading your CSV, running pandas, and saving a chart. It moves the AI from, just conversation to structured automation. It has hands.
Which leads us right into feature 4, identity and messenger support. This one felt very sci-fi to me.
This is where the rubber meets the road for how you interact with it. The agent has a persona and an authorization scope, but the key is integration. It supports cross-platform communication.
So it's not stuck in a browser tab.
Exactly. It can collaborate externally. It becomes an embedded participant in your operations. Think about your project's Slack channel or Teams chat.
The agent is just in there, like another team member.
Precisely. You can tag it like a coworker. At Manus, find me that report from last week.
And it just replies.
It replies, but because it's always on, it can also message you proactively. It doesn't have to wait to be tagged. If it finishes a task at 4 a.m., it'll post the result right in the channel.
Wow. That really does change the vibe from tool to coworker. It's just hanging out in the group chat.
And it has a distinct identity. It's not just system. It has a persona, which really helps with the social acceptance of it in a team.
Okay, now for the last one. Feature number 5. This one seemed the most complex. AI Subagents. A workforce.
This is a critical architectural difference. Traditional AI is usually a single agent.
Yeah.
You're talking to one model, one big brain trying to be a writer, a coder, an analyst, all at once.
The oracle on the mountain. Jack of all trades, master of none.
Pretty much. But Manus uses what the source calls an orchestration hierarchical structure. It's a multi-agent system. The primary agent, the one you're talking to, is like a project manager.
So it doesn't do all the work itself.
No, it delegates. It might assign a subagent to generate copy, another to analyze demographic data, and a third to format the final report. The source highlights this allows for parallel processing and role specialization.
It's a team.
It is. The source had that comparison table. Traditional AI is session-based and single agent. Manus is persistent and multi-agent. It's not a monolith.
So just to recap the stack here, we have the room, which is the dedicated instance, the brain, that's persistent memory, the hands are the skills,
Right.
the face is the identity in the chat, and the team is the subagents.
That covers the architecture perfectly.
So now let's walk through how this actually works. The source has a simplified workflow. It's a loop. Walk us through this, because this is where the always-on magic really happens.
Okay, so step 1. The agent receives an objective. And notice it says objective, not just a prompt. An objective is a goal, maybe a long-term one.
Like, monitor our competitors' pricing and let me know if they drop below this number.
Exactly. That's a continuous state, not a one-off task. So step 2. The agent delegates. It breaks down the objective and assigns tasks to its subagents.
Okay.
Step 3. It executes skills in its dedicated instance. This is the work happening, scraping the web, running the numbers.
And step 4.
Outputs are stored in persistent memory. It updates its own internal state. It learns from what just happened.
And then step 5.
It communicates the results via your messenger channels. Hey, I noticed a price drop, but here's the aha moment. Step 5 loops right back to step 1 or 2. The source explicitly says this loop runs indefinitely without requiring repeated prompts.
That's the game changer. It is set it and forget it, but for complex cognitive tasks.
It completely shifts the human's role. You go from being the driver to being the manager. You set the direction, but the machine drives the car, refuels it, and maps the route all by itself.
So what can you actually do with this? The source gave some use cases, and the first one that stood out to me was research.
Oh yeah, ongoing literature tracking and summarization. This is huge for anyone in academia or just for the learner profile you and I talk about. Imagine you're interested in, I don't know, solid-state batteries.
I am always interested in solid-state batteries.
Okay, so today you have to go search for news. With this, you just set the agent on it. It never stops reading. Every new paper, every article, it digests it, summarizes it, and adds it to your persistent knowledge base. You don't go looking for the news. The news is synthesized for you continuously.
A research assistant that never gets tired of reading. I love that. What about SaaS operations?
This is all about continuous oversight. Monitoring metrics, generating reports. In the software world, systems crash at 3 a.m.
The dreaded on-call shift.
Right. A human has to wake up and check a dashboard. This agent can watch that dashboard 24/7. But because it has Skills Remember Feature 3, it can do more than just send an alert. It could be authorized to restart the server or clear a cache and then send you a message saying, hey, this broke, but I already fixed it for you.
Marketing was another big one. Persistent campaign intelligence.
Right. If an ad isn't performing well at 2 a.m. on a Saturday, a human marketer is asleep. The always-on agent is awake. It could see the dip in performance and maybe pause the ad to save you budget or shift that money to a better performing ad.
And enterprise IT.
Basically, the ultimate IT support for routine issues, reduced manual intervention.
It all sounds incredibly powerful.
Yeah.
But, and there's always a but on this deep dive,
Yeah.
we have to do the reality check. The source material brings up limitations.
No, and it should. This is complex stuff. The first point is operational complexity. When you go from one agent to a team of agents, orchestration is hard.
What happens if the sub-agents disagree with each other?
Exactly. If the researcher finds data that contradicts what the writer wants to say, who wins? You need some serious orchestration logic. It's not just plug and play. Debugging a team of AIs is much harder than debugging a single script.
And then there's the cost.
Resource management. I mean, a dedicated compute instance is a computer that is running for you 24/7. That is just fundamentally more expensive than a shared session that only spins up when you type hello.
This isn't going to be a free feature.
Not a chance. The infrastructure costs are significant.
And what about governance? This feels like the biggest hurdle.
It is. The source notes persistent agents require clear authorization controls. We just talked about the agent pausing an ad or restarting a server. That involves spending real money or changing live infrastructure.
You don't want the intern having the master keys to the server room.
Precisely. If you have an agent that can autonomously execute skills, you need ironclad permissions. The source really emphasizes that these systems still require human oversight, especially for critical workflows. You need to be able to see an audit trail of what the agent did while you were asleep.
So we're not at the robot overlord stage. We still need to supervise.
It reduces the cognitive burden, absolutely, but it doesn't eliminate accountability. You're still the manager. If your always-on agent deletes the production database because it thought it was cleaning up, that's still on you.
That is a sobering thought. It's like giving the company car keys to a brand new driver.
Yeah.
You better trust them.
Or at least put a GPS tracker and a speed limiter on the car.
Exactly. Okay, let's wrap this up. We've gone from the frustration of the amnesiac chatbot all the way to this vision of a digital workforce.
Yeah, we're seeing a clear transition from just writing prompts to actual digital workforce automation. The big takeaways are reduced friction, context preservation, and task specialization.
It's a shift from a tool you pick up and put down to a partner that kind of walks alongside you.
Or, to use the source's language, it transforms AI from reactive help to autonomous partnership. And that's a subtle but profound difference in how we're going to relate to software.
And that leads me to something I've been thinking about this whole time. We've talked about the always-on nature, the fact that it's in our messengers, it has a persona, memory, it works while we sleep.
I think I see where you're going with this.
At what point does this stop being a tool we use and start becoming a coworker we manage? And if it is a coworker, are our current mental models of work even ready for that distinction?
That is the billion-dollar question, isn't it? We know how to manage humans, and we know how to use calculators. We don't really have a playbook for managing a calculator that acts like a human and has the agency to make decisions when we're not looking.
Something for you to think about the next time you leave your computer on overnight. Thanks for diving deep with us today.
Always a pleasure.
We'll catch you on the next one. Keep learning.